what's up, YouTube? It's your boy JOSHABRAHAM. And we are continuing with the introduction to general chemistry. Yes, a third semester student, but still I'm studying introduction to general chemistry. What's that? Oh, whoa. I got a reply from Willhaben. Okay, where is it? Oh, YouTube stream is on. Just a minute. Just a minute. Oh, come on. Just copy this, bro. Okay. Paste. I can't answer your questions right now because I don't know much. I need to plug in the PC and take a look. That's such a weird answer. So, yeah, I asked in Willhaben to a person like who posted a PC, and this guy did not post what power source it has, like 500 watts, 650 watts. This guy did not mention which power source it was using and the motherboard. So I asked him what is the motherboard and the power source, and this guy was like, I don't know. I should plug in to see what it's running. Why should you answer me in that? Like, you should plug it and see the results and let me know. Why should you answer in a way that I need to check? Okay, let me know. Fucking German. Okay, let me know when you get the details. Okay, sag mir Bescheid sobald. Okay. Monster. S orbital. P orbital has one planar node. S orbital has no nodes. Yeah. P orbital has angular node, means plane through nucleus. Okay. F orbital has three angular nodes are basically between angular node and planar node, because I don't get it. One node for each nucleus. Orbital shows identical degenerate energies. I think all the orbitals show identical. Angular node I started at a time of 30 minutes. Wijwal Yajnik. Yo, what's going? Hey, yo, my man. Appreciate for checking out the stream. Yeah, I was checking out introductions to general chemistry. I'm having the exam next month, so I got about 15-20 days. Hi, hello. I appreciate Wijwal Yajnik for checking out the stream, and I do apologize for the uh, what's it called? The latency. So, angular node, a region where wave function is zero because of the orbital's angular part, meaning the direction of electron is. Mhm. Radial node, a region where the wave function is zero because of the radial part, meaning the distance from the nucleus. Always just very close. So only S subshell have radial node and the others be having angular node. Instead of angular node, you should write it planar node. No, that's not correct. Every orbital type have radial nodes. Radial nodes depends only on. Okay, what is the radial node here? 3p. Okay, I'm confused on the radial node in the p orbital. Could you explain on that? Have you tried watching the lecture of the organic chemistry tutor guy? Yeah, I used to watch this guy whenever I need some topics explained. Yes, I do know this guy, but I don't know if he has this part explained. You know what? Just so you said, I could check it out. Uh, you know what? This guy does have one video. But I need to know if this guy explains what I need to know. The comments. You know it's bad when you still don't understand after the organic tutor explained it. So my main questions were, here's the clean confusion. Oh, come on. Twin, it's sick, but since you're learning about structure of atom, you should check out Structure of Atom lecture by PW. But it's in my native language, so you can translate it anyhow. Okay. PW, that's a new channel? Huh?
Levels, sublevels, quantum numbers, and things like that. Now, an orbital is simply the most probable location to find an electron. So let's say this is the nucleus. We're going to consider the Bohr model of the atom. So I'm going to draw circular orbits. So this is going to be the first energy level, n equals 1. And here we have the second energy level, n equals 2.
What's PW?
And here's the third energy level, n equals 3. An
Oh,
electron
physics
occupies
wala.
the third
Okay, I
energy
heard of
level,
this.
has more energy than one that occupies the second energy
But,
level.
it's too long.
N represents the principal quantum number. It describes the size and the energy of
Oh,
that
it's in
orbital.
Hindi, bro. I mean, I think
So as n increases, the
there's an
distance
option to.
from the nucleus increases as well. So electrons that are closer to the nucleus exist
I
at lower
mean,
energy levels.
yeah, I think
Electrons
there's
that
an
are further
option
away
to
from the
have
nucleus
subtitles in English,
exist
but
at higher energy levels.
that's still gonna hurt.
So that's the first quantum number that you need
I
to be
know this
familiar
guy,
with.
physics walla.
So n is the principal quantum number. So keep in mind, n is associated with the energy level. L is the angular momentum quantum number, and it describes the shape of the orbital. So when L is 0, what you have is the s orbital. And so this orbital looks like a sphere. When L is 1, you have the p orbital, which looks like a dumbbell. And when L is 2, you have the d orbital, which is a cloverleaf for the most part. And when L is 3, you have the f orbital, which looks pretty strange, which I'm not going to draw in this video. So just keep that in mind. L describes the shape of the orbital, and n, the principal quantum number, describes the size and the energy level of that orbital.
I'm
By the way,
prepping for competitive
S
exams,
also
so I have to
corresponds to
sit
the
in
sun.
those 7 hour
It
long
describes the
ass
shape of the
lectures.
orbital, but you can also
Are you preparing for JEE exams or NEET? Cause that's pretty amazing. What was I was gonna ask something? Yeah, 3p orbitals, 3. Mm-hmm. Okay, the sphere is this one. Okay. Is that also the node of the previous subshell? No, the radial node. No, I'm asking radial. I'm asking about the spherical radial node seen in 3p. Is it as part of the s orbital of lower energy levels? That's my question. It's a yes or no question. Don't clarify this. In short, the spherical node 3p is a zero probability shell intrinsic to the 3p orbital, but it's not an s orbital itself. But even if it's coincides spatially with where a lower s orbital why do you have to dismiss that statement? Like it is staying exactly where the last s orbital node is. So it is basically also where the n
as the sublevel. Now let's talk about the relationship between n and L. L is always less than or equal to n minus 1. So when n is 1, you can only have one value for L, that's 0, which corresponds to the S sublevel. Now when n is 2, L can be 0 or 1, but not 2. So in the second energy level, you can have the S sublevel and the P sublevel. In the third energy level, L can be 0, 1, or 2.
Okay, so wait. The radial node of 3p happens to appear at the radius similar to the outer part of the 2s orbital, but it's not the same node. It belongs. So it's outer part of 2s orbital. Uh-huh. So okay. So it's like a point. Yes, JEE it is. I respect that, brother. That's that is a really hard exam from what I heard. I also tried one of those exams. It's called the NEET. I remember those times. And I did pass the NEET exam, but I was nowhere good enough for admission for medical universities. So I followed my dream. So it's like a point of no probability hollow sphere 3p and 2s orbitals.
So the third level can exist. The 4S sublevel, the 4P sublevel, the
I
orientation.
know this.
Dare to dream to eat.
Of the orbital relative.
That's orientation.
Now, for S, we know that L is 0. For P, L is 1. ml will always vary between negative L and L. So in this example, L is 0, so
We have had a
has to be
history
0.
of problems
Now
for
P, L
admission
is
due to
1, so ml
reservation
is
in
going to be
uni. Oh, I I'm not. I'm just saying. I heard that the exam is getting tougher, or you know, the reservation. I heard of it, but it's like the competition is so high, right? 15. I'm just talking about NEET. It's like 15 lakhs of students writing the exam. Only 2 lakhs get into a university. It's on one side, it's like yeah, they're going for the best students. The other side is like a lot of students. If they want to get into the university, they gotta prepare one more year. Like, is it lack of more universities? I don't know.
between negative 1 and 1, including 0. So notice that ml describes each orbital in the p sublevel. The p sublevel has 3 orbitals. You have px, py, and pz. So px is in basically along the x-axis. Py is
So
along the
that's
y-axis.
basically
And then you have pz, which is along the z-axis. And so these 3 orbitals within the p sublevel has different orientations. So one of these numbers corresponds to px, one of them corresponds to py, and the last one corresponds to pz. It doesn't have to be in that order, but each orbital corresponds to one of these designations. L is, and it's only, so according to Pauli's exclusion principle, every electron within an atom has a unique set of 4 quantum numbers. So you can think of those 4 quantum numbers as the address of each electron within an atom. So let's say if we want to talk about the 2p5 electron, what are the 4 n? The principal quantum number corresponds to the number that you see in front. So n is 2. That means this electron is in the 2nd energy level. L is based on the sublevel P. Now if you recall, S has an L value of 0, P has an L value of 1, D has an L value of 2, and F has an L value of 3. So L is 1. Now we need to find the ML value. So what you want to do is draw the orbitals that's found in the P sublevel. Keep in mind, P has 3 orbitals. Now because L is 1, ML is going to vary between negative 1 and 1. Now we need to focus on the 5th electron in the P sublevel. So here's the first one, the 2nd, the 3rd, the 4th, and the 5th. So the 5th electron is found in this orbital, which has an ML value of 0. Now the electrons spin based on what we have here. We have a down arrow, so the spin is minus 1/2. So that's a quick and simple way in which you could find the 4 quantum numbers that corresponds to a specific electron. So let's try one more example. Go ahead and find the 4 quantum numbers that corresponds to the 3d5 electron. You can pause the video if you want to. Now the easiest one to see is the number in front of the D sublevel. So N is 3. This number corresponds to the energy level. Now what is the L value for the D sublevel? Keep in mind, L is 0 for S, L is 1 for P, and for the D sublevel, L is equal to 2. Now within the D sublevel, we have 5 orbitals. And if L is 2, ML is going to vary between negative L and L. So it's going to vary between negative 2 and positive 2. So now we're looking for the fifth electron. So this is going to be the first one, the second, the third, the fourth, so here's the fifth one. So the fifth electron is in this orbital.
The angular node of 3p orbital is independent of the radial node. How this works? Radial node is pretty sure where probability 0. Radial node is. If you wanna observe the electrons on the 3p subshell, the probability of seeing one angular node are 0. So I'm guessing the angular node and radial node have something have yes, exactly. In 3p orbital, the radial node and the angular node can intersect in space. Okay. Yes, okay, that makes sense. At the radial node, the probability of finding the electron is 0. All the sphere. Okay. Just a minute. I gotta get some water. I need to explore the d orbital, like the nodes. I just need to confirm how the nodes are gonna be. F orbital, I'm just gonna. Uh, Wujval Yajnik and Clonopin Commander. If you guys don't mind, I'm gonna refresh the chat. Cause yeah, cause it's gonna look a bit. Yes, appreciate that. P orbital. How are the angular and radial nodes for the F and D orbitals? I know F has two angular nodes and D has three angular nodes. No, D has. Yeah, D has two, F has three. Yeah. Number of radial nodes is n minus L. Okay, okay, okay. The orbital. No circle, no. So 4D has one spherical node. Hmm. Interesting. Why this 3D? Mm-hmm. Okay, I get the radial node being a sphere. I got that. But how are the order? Wait, there's a way to. Mm-hmm. From 40. Okay. So 40 only comes up after 1S, 2S, 2P, 3S, 3P, 3D. Oh wait, 2S, 3S, 3P, 4S, 3D, 4P, 4D, no, 4P. 30 minutes? God damn it! Come on! Hey Siri, set a time for 30 minutes. Push ups. Want us to. So 40 comes up after 5s. So the radial node we're seeing is part of 5s. Yep. 3 3p 3p also has a radial node. It's part of 3s. Okay. F orbital, of course. F orbital has part of 6s. Okay. Mm. So let's just now take the orbitals 6s and 4f. The s orbital is of the of the energy level apply energy to the electron at the 6s orbital will it higher level, which is 4f? If so, uh, the energy levels of the orbitals just strictly increase with n alone. The total energy of the electron depends on the n and l. Even though 6s has higher principal quantum number, the energy of the 6s is usually lower than f. Okay. So in 6s cannot jump to 4f unless you provide exactly the energy difference. Okay. Usually in atoms with many electrons, 4f orbitals are more tightly bound than 6s, so electrons would need a lot of energy to go there. Key takeaways: n alone distance. Okay. Easier, less. Mm-hmm. Now my problem would be to write the SPDF orbitals on my own. What do I write? S orbital. S orbital has so I'm just gonna understood about the orbitals. The S orbital have only one radial node, then p orbital and occasionally but usually they don't even explain. I mean, the n equals 1 having no nodes, you're not gonna find electron at the center of the atom, the nucleus. So, if we think about it, n equals 1 should have a node at the center of the atom. Usually have only one radial node. The p orbital usually has one angular node and occasionally radial node. Then d orbital has two angular nodes and occasionally uh, mainly when the subshell just below is a s orbital. F orbital has what? Three angular nodes and one radial node. the I forgot about the orientations, right? No angular nor spherical symmetry. Uh, Angular nodes are determined solely by orbital shapes. Radial nodes are depends on okay. The angular nodes depend mainly on the what's L. Okay, angular momentum quantum number. Okay, angular nodes depend on the subshells. Can I tell these things as subshells? Are orbitals and subshells the same thing? Because I'm on. Not exactly, but they're closely related. Subshell, a group of orbitals with. Oh, okay. Subshell. Okay. Uh huh. Orbital, a single region where there's high probability of finding an electron. Subshells, group of orbitals. Okay, so subshell depends on the number, like the energy level number, principal quantum number. Uh, One box. So subshell is principal quantum number dependent, while the orbital is L dependent. How are the numbers? S has all the numbers. P for okay, P has all the numbers. P starts from 3. No, P starts from 2. D starts from 3 and F starts from 4. S P D. Okay. Almost right, but let me clarify this precisely. Subshell defined by the principal quadrant number, so subshell depends on both, not just n, for example. Yeah. Orbitals, single region where subshells where an electron can exist. Magnetic quantum number determines how many orbitals are in the subshell. Okay. Three orbitals. Okay. Uh-huh. So orbitals are basically uh, how electrons are arranged on a specific subshell. are uh, where electrons are arranged in a specific subshell shape. I think that's basically it. So what does s orbitals? Spherical shape, two electrons, uh, one orientation, right? One orientation. SP orbital has three orientations. D orbital has five orientations. F orbital has seven orientation. No. Oh yeah. Yeah, yeah. Okay. Uh, what do I write? Spherical shape. Is there anything else? How many electrons does S2P P326 D10 F has 14. Okay. Come on. Damn. That looks clean. Dude, this thing's you have to charge this. Apple. The fuck is wrong with you, Apple? You can't hold two electrons. No orientation. Okay. Please, Lord, don't make me do this again. I'll write this again. And don't make me forget shit. What am I doing? I'm trying to show how the node is gonna look like, bro. Come on. How would you show the nodes? Uh, I'm not exactly sure that's a node, but you could. This is where the electron should be. You know, spherical shape. No. Two electrons. How does a radial node looks like? Now, so that's basically S orbital. It's a spherical shape, no orientation. Now p orbital. Oh, come on. I forgot that it was not sharing on the main screen. P orbital. Dumbbell shape. Three. Px. Py. Oh, come on. That's not straight. Those are nodes. One angular node, mainly. One radial node if the orbital just below the P1 is S. bit too big. No, 2s. I believe that's 2s. Oh, Apple Pencil 5%. Go fuck yourself, bro. So that's basically p orbital. Do I have to mention anything else? Oh yeah, and p d. Clover leaf shape. Now it's the hard part. 30 minutes? Fuck you, bro. You know what? I'm pretty confused, like how different orientations work, but I believe it's just taking the extra space that these guys did not take. P orbitals. 5 possible orientation. Two angular nodes. radial node when the orbital just below is S. How do I show that? Those are radial nodes. Oh, I forgot the example. How was it? This would be this would be 3D, and this would be 5S. Oh, I could cross verify, right? So oh, come on. 3D 4S. So that would be 4S. 4S. Those are some notes. Now the last one, F orbital. This has, what was the shape of F orbital? Oh, it's more complex geometry. There's no shape. 7 possible outcome. 6 electrons. This would be 10 electrons. Seven possible outcomes, +3, +2, +1, 0, -1, -2, -3, yeah. Now, 3 angular nodes. The same case applies here, bro, come on. How do I show F orbital with the radial node? I gotta show the F orbital, just a minute. How do I get access to the F orbital? No, not that one. I need the... Yep. Where is it? Um, I'm sorry. I gotta make for F success. Okay, I think how many electrons? 14 electrons inside. So these are basically the four orbitals. Uh, yeah, I'm actually sorry for not throwing the F orbital. Not that good. It's a bit. Oh, bro, I wish I could draw the F orbital, but it's a more three-dimensional shape. Okay, well that's basically the orbitals. Now I gotta look at the rest. You know what? It's already 30 minutes, right? Uh, yeah, so I'm done with the. I am done with this one. Now I have to continue with biochemical kinetics. Yeah, yeah. Okay, YouTube, I'm gonna end the stream and I'm gonna restart with biochemical kinetics. Peace! Or I'm gonna restart with sequence analysis. One of these two. Peace!